So, and for some reason, it's always about context. I don't know why. People just find that particularly intimidating.
Yeah.
I think that's probably, that would probably be the top three on my list of things that scare people about Go is interfaces, concurrency, and contexts.
Yeah, exactly. I also fall under that category, you know,
So
of people who got, yeah, actually I had to read about context exclusively for a whole day to just soak it in and understand it. And I read it from a third party, random blog. I don't know where I found it. I can't really recall, but it had a good explanation of the context package.
yeah, it's
Yeah,
it's nowhere near as scary
yeah,
as it seems, is it? Because
yeah,
it really isn't anything at all. It's just,
yeah.
you know, before we had context, which is a relatively new thing in Go, what did we used to do is we just used to pass some variable or something, or pass a cancel function or something, or return a cancel function, or you know, a little struct to store things
Yeah.
in. And context is just a standardized way of doing that, isn't it? It
Ac-
just says
Actually,
if you're
mhm,
going to pass something through the entire
mhm,
request chain, let's just make it a standard thing.
mhm, yeah.
And maybe we never
I don't
touch
know.
it. I mean,
Yeah.
what does everybody do? Just call context.background, right? And just pass it
Yeah.
to things. It's like I don't know what this is for, but apparently I need one.
Sure, sure. Yeah. I don't know whether it's a good thing that I don't know whether it's a good thing that I started using Go after the context package had been introduced or not, because coming from I came from Node.js.
Hmm,
I didn't have all those context. I just use middlewares and that's it.
right. So I think it's
Yeah.
one of those sort of necessary evils. It's like,
Yeah.
um, if we don't have to take context, then let's not, because it just clutters up our API.
Yeah.
Um,
Yeah.
and even if there's something, we're calling some function which calls some other function which calls something else which could potentially
Yeah.
time out. Maybe we
Yeah.
don't need to pass a context through that entire chain. Maybe it's only the last function that needs to create a context.
Yeah, which also brings me to this question, if I may ask about context.
Yeah, ask away.
Um, Now, you might have a client that is consuming your service, and you have all these contexts well set up. You have them cascading through your request lifecycle, and then you receive the client terminates. Times out,
Hmm.
and your server, the context signals every other context in the chain that we received a timeout about what you're doing, and
Yeah.
receive another request. So my question was, what if it's a long running task and the client cannot wait for that task to finish?
Hmm.
Instead, it times out, and you need to, on the server side, you need to continue processing, then at a later time return the results to the client. How do you differentiate such a scenario to the normal scenario where the users just typed control C?
Yeah. Yeah, that's a good
You
question,
see,
isn't it?
yeah, that's something I've been pondering about for the last several days.
Yeah. What we're really saying is it's a situation where some operation takes longer than we have, isn't it?
Yeah, yeah.
But
How do you
for
get to
whatever
know?
reason, yeah. Maybe
Yeah.
it's normally this is quite fast, but because
Mhm.
some endpoint is down, it's just not returning. So we need to detect that and just cut it off. We don't want the user
Yeah,
waiting 10 seconds.
yeah,
Or alternatively, normally we would have plenty of time and it doesn't take long, but we just got control seed, as you said.
yeah,
So I think we have to sort of distinguish between can can we reasonably predict in advance that this is likely to take longer than we have, in which case sounds like we need some sort of go routine, doesn't it?
yeah,
Spin up some concurrent thing and then say just notify me on this channel when you're done, or even just send me an email or whatever. It's asynchronous, that's the point.
yeah,
Or alternatively, it's like normally this will be okay, but it might just happen that for weird reasons we want to cancel or something, which sounds more like context, doesn't it?
yeah, exactly.
So I think that's, if you're going to do some long-running asynchronous process, then just build that machinery, build it as a normal concurrent program. Still take context, just to give us a way of controlling those Go
Yeah.
routines. Go routines easy to start, but hard to keep track of and hard to kill.
Yeah, I agree.
So context is a nice way to do that. And
Okay.
you also have to listen to the context, don't you? Which is something that a
Yeah.
lot of people miss out, is they create contexts and pass them around, but then they never actually listen to the context's done channel, which is the point of it, of course.
Yeah.
It's going to
Yeah.
send you a message on that channel when it wants you to quit. So if you're not listening, it just won't work.
True.
And I see a lot of programs where this is in fact the case. They pass this context around the entire program, and then it turns out it was all a waste of time because they don't quit.
I, I also was in a dilemma in this project. Actually, I can show you if I may.
Yeah,
Let me show you here. Let's just go here.
I think
And
this is likely to be a pain point for a lot of people, isn't it?
yeah, you see right now here. Like here, right here. I'm passing a context, right?
Hmm.
You would be. I was tempted. You see, okay, let me explain. I'm passing a context, so I'm assuming when the context, receives a shutdown signal on the done channel, the except context will receive that signal on the context done channel, right?
Yeah,
Done method, right? So I was tempted to also listen to the context myself above here, but then I figured that I don't need to do so because once exec context receives that signal, it will error here and
yeah,
it will tell me. And actually, I did a POC, a proof of concept, and I saw the the messages that will be returned are the same, but one of them would have would be appended, would have like a will notify you that it comes from the exec context. I guess the library author wraps the error
yeah. I don't
inside.
know if that's the case, but it sounds absolutely reasonable to me. And I
Yeah,
think you're
so
dead right. I don't think you need to do anything because
yeah, actually,
you're not the end of the chain, are you? That's the thing. It's only the end of the
yeah,
chain that needs to listen to the context.
yeah, exactly. But
Um,
that's a dilemma I got into recently, but then I didn't have the confidence, to make a decision at that point. That's why I went back to that blog I told you about and read about context. And once I felt confident enough, I came back and I deleted that code.
yeah, it's great.
Yeah,
And
yeah,
and it's also really awkward to listen to a context if you're not already listening to some channel, isn't it? Because if you
yeah,
already have a select statement, it's easy to add the ctx dot done. But if you don't, what are you going to do? You're going to write some sort of for select that only
yeah.
listens to that done channel and then has a default case so it doesn't block. But that's a whole lot of machinery just to do basically nothing.
Yeah, I agree.
So it's very annoying.
Yeah.
So that's great. So just returning to that test for a moment, I
Okay.
see that um, you have. So what you basically do is you say create a new user given my test database,
Hmm.
check if that failed or not, and then I look at the created at field,
Yeah.
and then I say how long is it since then? Was that more than 3 seconds ago?
Yeah.
In which case, that something's gone wrong, right?
Yeah.
Like, what are you really testing here? Are you testing that it just doesn't take too long?
I was just being paranoid. Like, you might have created a user way before,
Right, yeah, I see what you mean.
way,
So it might
yeah,
have already
yeah,
been in there,
yeah,
and you
being
didn't do
there.
anything, yeah.
Yeah. So I was just trying to, I, I don't know. I'm a sucker for punishment. Sometimes I just like, to make, I like making life easier, but then I like to ensure that I actually get the work done the right way. So I initially, before I wrote this, I would found that the created art was way behind,
Mm,
minutes ago. So I just wanted to know whether it's me creating the user or it's some other, it could be a demon running,
yeah.
creating users. Who knows?
Yeah, this is a
Yeah.
really common pattern with any sort of CRUD operations, isn't it? Like
Yeah.
we create the thing, then we look to say, did we succeed in creating the thing, and can we get the same thing back? And
Yeah, exactly.
you're sort of asserting some behavior about the state of the store, aren't you? You're saying,
Mm,
if I start with an empty store and then I create a user, there should be exactly one user in that store, and it should be this one.
yeah, yeah,
Or you're saying, whatever state the store is in, I don't know. If I create user X, then I should be able to retrieve user X, and I should be able to know it's the one I just created, not one from a previous test run or some other test or something. So the logic of the first approach means we kind of either need our own store exclusive to this test, or we need to be able to wipe the store
yeah,
and start fresh, isn't it? Like, it's what I call setup world stuff. Either we need our own world, or we need to be able to nuke the world and start fresh. Creating your own thing is okay, but that's usually quite expensive to spin up an entire world for every
yeah,
test.
yeah, I agree.
And nuking the world is also not good because we want to run a bunch of parallel tests against the same world. So that
Yeah,
implies we don't have the keys to it. We don't
yeah,
have control over the state because other people are trying to do stuff. We will just blow up those tests.
sure.
So the ideal test, from my point of view, is
Okay,
one that just says, I'm going to take the world as it is.
okay.
I assume
Mm-hmm.
I'm operating in a shared world,
Mm-hmm.
shared store or whatever.
Yeah,
I
yeah,
assume other tests are constantly reading and writing it.
okay.
So I can't assume anything about the state, even from moment to moment. If I do something and then look a minute later, it may not be there. That can
Oh,
happen.
yeah,
So I can't
yeah, I
make any
get you.
assumptions about that. So what I want to do is just say, you know, all I know is about what I did. You know, maybe I open a transaction and then I do stuff, and then I don't care about anything that happens in other transactions. And if it doesn't work, I just roll back.
Yeah.
Either way, I think that's sort of, that's more difficult from the point of view of writing tests, since you can make no safe assumptions about the state of the world.
Yeah.
But it also leads to a better design, because what you get is something that's extremely parallel and extremely concurrency safe, isn't it?
Yeah. Yeah. So that means with that said, that means you wouldn't have to counter check the scenes created and whatnot, the verification here, right?
I think, well, I'll tell you what I like about this, because I always think it's good to find something nice to say. What
Okay.
I like about this is that you didn't simply subtract time.now from created time. And you see people do this a lot, is they just,
Well,
they
well,
just,
you didn't ask if I had done that earlier. I
yeah,
would
well,
have told you.
we'll pass politely over that. Um,
Yeah.
but I see a lot of people do this. They do math with time.time objects, and that's just fundamentally not safe. And zero. What does a zero time.time mean? It doesn't mean anything, and it probably won't be zero, even if it really is.
Yeah.
So we actually have these time.Since and time.Before and time.After, isn't it?
Yeah. Sure.
Which we can use for this. So if you are manipulating times, that's
Mm.
the safe way to do it. Just pretend you don't know that the time is really a number. you
Yeah.
know, it's really some int64 number of nanoseconds, but we'll pretend we don't know that, and we'll just treat it as a completely opaque object that we can call methods on. That's fine. So what I might do here, or what you
Okay.
might think about doing,
Mm-hmm.
is say, what am I really testing here? What I'm really testing is that I can create a user, isn't it?
Yeah.
So I can call new user, and I can
Okay.
check that that works. I can look to say, does that user exist? Great, that works.
Yeah.
But what if that user was already there and in fact I did nothing? Well, what I can do before calling new is I can delete that user.
Okay.
I can say, delete user Fred if he exists. Now, new user Fred, does Fred exist? If I do those three steps in that order, then I've tested what I'm really testing out there.
True. True. Oh yeah, makes sense. Makes sense actually, and that spares me all, because if I had other fields, other time fields here, that means I would have to write extra code checking whether I really created them, right?
Yeah,
That would spare me that pain, right?
exactly.
Paperwork.
This is very much the shared world approach. Is we're not relying on an empty
Okay.
world because it won't be. All we're saying is I'm going to clear out my little corner of it, and then I'm going to do what I need to do, and I can look at my little corner to say, did it happen? I don't care about what anyone else is doing. I'm sure there are millions of other users created by other tests. That's fine. I'm not looking at those.
Yeah, sure.
So I need to make sure that whatever my user ID is, it's unique to this test, isn't it?
Yeah.
And maybe
Mm,
I actually create some UUID for that purpose, just so I can guarantee it. It would be too easy for someone to come along and copy and paste this test and create a new one, also testing the same user, and then they get confused with each other. So I think that might be a helpful
yeah,
way to
I
think
think
about it.
I agree. I agree because I was skeptical, a little bit skeptical, because as you can see here, I have so many time fields. You can see here, we set password verification, and I'm assuming
Yeah,
in future they will increase.
yeah, that seems
You
like a
know,
lot, doesn't it?
yeah, a lot. Yeah,
Yeah, maybe we can do something there. But we
yeah.
would better wrap up for today because you've already donated lots of
Okay,
your time. And thank you very
sure.
much for that. I appreciate it. And also thank you for, being brave enough to put yourself out there, put your program out there and
Yeah.
and sort of expose it to be torn to pieces by people. That's great.
Um,
And
I'm
we've done.
also I'm also thankful for having me.
No, it's a pleasure. And we've done a lot of good stuff, haven't we? I mean, we've
Yeah.
we've definitely found some places where we can improve this program, but also sort of maybe give people ideas about their own programs. One, just to do this process, reading it, looking for stuff to refactor, looking not to say, I hope this proves my theory that the program is correct, but looking at it saying, I'm sure it's wrong. Where is it wrong? What can I find?
Yeah.
That's a useful mindset. And also some ideas about what we're thinking about when we're refactoring. What are we trying to do? What kind of program are we trying to create? A simpler one, a clearer one, a shorter one, maybe a faster one. I probably
Yeah.
don't really care about that. It's probably fast enough. But if it gets faster as a result of this, great. I'll take that. I'll take the win.
Yeah. Of course.
So that's wonderful. Thank you very much for being with us in this inaugural session of the Refactory. And for everyone watching at home, thanks. And I'll see you next time.
Bye.
Bye, bye for now.